Welcome to today's Energy Central Power Session entitled Network Visibility, a Path to Increased Grid Reliability, Performance, and Safety. Before we begin, I'd like to take a moment to thank NetScout for sponsoring today's event. Now I'd like to turn the floor over to Mike Smith, who's moderating today's event to help kick things off. Mike, welcome to the event. You have the floor.
Well, thank you, PJ, and also thanks to NetScout for sponsoring this. Thanks to our panelists who you are going to be meeting here in just a few minutes. And thanks to you all for joining us. I think we've been fortunate enough to get a good group put together for today's session. And I think you're going to hear some great experiences, some great actionable insights that'll help you all navigate and manage the many challenges at your utility. So PJ, if you could jump to the next slide. I wanted to take just a few minutes before we get into the panel discussion, just to talk a little bit about some of the things that are happening at a fairly high level in the utility industry that ultimately are driving a lot of the infrastructure needs, including the network. And that's something we're going to dive really into during today's session. But when you start thinking about the growth of distributed energy resources, that aging infrastructure, the regulatory climate, and also these massive smart grid investments. If you think about the business needs behind all of these and what are those key enablers behind these business needs, it gets pretty interesting and pretty complicated pretty quickly. But you'll see today we're going to be talking a lot about that infrastructure and what I like to call those underpinnings that enable a lot of the smart grid that actually enable a lot of this new energy environment that we're all moving into. So we have a few examples and data points on that. So PJ, next slide. The first is just infrastructure spending. I think we all know we have an aging infrastructure, and when you look at the scope of that and you look at some of the industry data out here, I just pulled one data point where the Edison Electric Institute was estimating over $100 billion in infrastructure spending over the coming year. I think a lot of that will be on things like transmission, which is going to be super important when you start talking about grid scale renewables, but also just a lot on maintaining what is out there and building new where we need to build new. A second data point that I'll point to is, there it is, smart grid spending. You know, I think if you all have been around the industry a while, you can remember when smart grid first kind of came into the lexicon, gosh, close to 20 years ago now. And there was a very big spend initially, but that spend continues. That's not going away. This is on devices, on communication networks, on different software for different applications and use cases. And that's not going away because, again, that smart grid and the networks therein are enabling a lot of the things that our new energy environment is going to look like. And there's a lot of dynamics around that that we'll be getting into as well. And then a final data point is telecom spending. Utilities spend a lot of money on telecom, and sometimes as an industry we don't talk about this very much, but what I always come back to when I'm thinking about this and doing work with Energy Central or with some of our customers and partners is what are some of those enablers behind a lot of these critical use cases for this new energy environment where the old models around centralized generation are now being replaced with distributed generation, where that role of the customer is no longer static, but it is very dynamic. And what's happening at that intersection of the grid and the customer that's really changing that landscape. So these are a few of the things that we'll be getting into today, but I would like to jump ahead now and start with the panel discussion. And I will start by introducing our first panelist, and then I'm going to ask him a question to kick us off. So Adam Nathan is the Area Director for Utilities and Energy Industry for Worldwide Technologies. Adam has been at WWT for 10 years, all of which were spent serving in the energy and utility industries in a mix of sales leadership, business development, and management consulting roles. In addition, Adam is a member of the Board of Directors of the Utility Broadband Alliance, serving the industry in an effort to improve telecom infrastructure and operations. So Adam, thanks so much for joining us. And as with our other panelists today, I've enjoyed some of the prep work and discussions we've had leading into this. I do want to open up our discussion with one of the things that you talked about in one of our prep calls, where when we spoke, you talked about how the utility really needs to look at their systems as kind of like being a nervous system, and that's particularly critical for this environment we're operating in today. So you have kind of a model that's pretty compelling, where there's an analogy between the nervous system of a person and the nervous system that's required for utility to really fire on all cylinders. I think I'm mixing metaphors now. Can you maybe share one aspect of that model that underscores the role of the network in this new area, again, reflecting on that nervous system analogy?
Yeah, absolutely. First of all, thank you very much for having me on the panel today. I'm excited to talk to the group here. Yeah, we live in a world of analogies, and as we're trying to digest the changing environments we're in, and so this analogy that we use is there are really three main components to a nervous system. There's the receptors in the ears, eyes, nose, mouth, skin that create information about the world around us. The nerves that move that information around the body, ultimately to a place where we can apply cognition. Most of that's in the brain. We store that information, we analyze it, we integrate it, and then we turn that into insight and action. But it also happens at the edge. You touch something hot, that cognition is applied at the edge. That message doesn't go to the brain before you move your hand. As we digitize the grid, we need all three aspects of that. We need the sensors at the edge that are creating information about what's going on the grid and the world that the grid is operating in. We need the nerves, the networks that move that information around from the far edge to the near edge to the central data centers. And then we need the information architecture and the applications to turn that raw data into insight and action. So when we think about the networks, it truly is a third of what we're talking about in this analogy, and a third of our focus, actually probably a larger, an outsized portion of our focus, because it is so foundational when we think about everything from, everything that is a digitized grid, from SCADA to AMR to AMI to distribution automation. We're talking about things like energy orchestration now. These are all use cases and critical capabilities underlying the smart grid moving forward, and sort of from the 1980s and earlier, around SCADA, all the way through to energy orchestration in the future that we're seeing, where the connectivity to those devices, and in order to be able to see what's going on the grid, but then also to then take action without having to roll a truck each time, is critical, and only getting more critical. And so that network is only increasing in criticality for all of, it's basically every smart grid related use case requires that increased resiliency and pervasiveness of the network.
Yeah, and as you were commenting, and that was a great way to kick us off, by the way. I was loving that you used the term energy orchestration. I've come across this a few times recently, and I want to ask you kind of a tangential or a follow-up question. I don't think I heard you use the words real time to near real time, and I think that is something that is a huge differentiator, because when you start talking about DERMS, or even some of these energy markets at the distribution level that FERC 2222 is starting to talk about, this element of not just having connectivity, just not having data, but that real to near real time element is super, super important. Are you running into that a lot at utilities, where they're saying, this is great, but it needs to be faster, or what have you? So are you running into that, where that real time need is becoming very tangible?
Absolutely. And these are utilities, right? We're thinking in not 1 to 2 year cycles, but 5, 10, 20 year cycles. Right. Knowing that if you've got a service territory of thousands to tens of thousands of square miles, where you have assets strewn about, hundreds of thousands of assets, thousands of miles of wires, fiber and electrical wires, and then all the equipment that goes along with that, it's really to upgrade the networks to be able to communicate to assets that live across that kind of service territory and footprint is a multi-year, at a minimum, a multi-year effort, and can be a decade or more. And we see what it's taken to get the fiber backbones of most of these utilities to where it is. This is generational investment. And so we can't just be thinking about, as we think about something like DERMS or energy orchestration. We can't just be thinking about point solutions or individual locations that we're connecting. It needs, and the reason why we think about the digital nervous system the way we do is we need each of those aspects, the receptors, the nerves, and the cognition, to be scalable platforms that enable use cases we can't think of today. I like the example of Uber, and I know it's an overused analogy, but if we think about it, the Google first released Google Maps in 2005. The iPhone came out in 2007, and late 2009, the first 4G network was released publicly for consumer use. It was 12 months later after that third piece. So you had the world was mapped, and so some of that cognition was there. You had the devices at the edge and the iPhone and other smartphones coming out, and then you had the networks come out in late 2009. None of that was built to enable us to transport ourselves using something like an Uber, but having those foundational platforms there enabled the development of an application no one thought was necessary. And now it's changed the way we get ourselves around. I think there are many, many examples of those kinds of use cases in this industry, but no one's going to deploy all of the devices for us or map all of the assets. And what we've seen is we need to have a more focused effort in or continued investment in expanding the platform that is utility communications platforms.
Agreed, and you're right. It is a journey. There may not ever even be a final destination. It's always a journey. So yeah, good stuff. Great way to open us up. By the way, just a quick note, I did see that PJ put a note in the chat. We encourage y'all to ask questions and jump in anytime. Just put them into the chat. I have access to that, and PJ's helping me manage that. So we would love to hear from you all in the audience as well. So I'm going to introduce our second panelist, and I'm also going to ask her a good question to kind of kick us off from what she's seeing in the space. So Bree Swierstock is the Manager of Telecom Operations and Maintenance at SMUD. Full disclosure, I am a SMUD customer, and I'm a happy SMUD customer. Bree, thank you to you and your colleagues for keeping the lights on and the rates down. Bree has over 13 years of experience in utilities, including a decade specifically in utility operations. She holds an MBA from Cal State Sacramento and is passionate about driving operational excellence and fostering positive change within her organization. She is dedicated to building trust and breaking down barriers to enhance collaboration and efficiency. Bree is also a participant in the 2025 Utility 2030 Radiate program, furthering her commitment to innovation, leadership, and empowering women in the utility sector. So Bree, thank you for joining us. I do want to ask you a question that kind of takes off where we just talked with Adam and get a little more specific about some things happening there at SMUD. So you're right in the middle of all things telecom at SMUD, which is a pretty interesting place to be, considering SMUD has really been kind of tip of the spear on a lot of the smart grid and smart metering initiatives over the last 15 years. So where do you see SMUD leveraging telecom investments to operate the grid, serve customers? As you look at that, where are you seeing opportunities where SMUD's telecom investments are enabling some of this reliability, performance, and safety that we're talking about today? So maybe just a couple examples of where, hey, this robust telecom network is enabling us to do these things. So maybe just a couple examples there so we can kind of see what it looks like in action.
Sure. So I do want to start by saying thank you so much for having me. It's really exciting to be on this panel and have this discussion about a topic that I'm pretty passionate about. Investing in telecom, it pays dividends. Adam was talking about us being more focused on expanding our networks. And I think sometimes we think of it as an afterthought. We know what the end game is, but we want to make sure we have the infrastructure in place to do it. We've been making some big investments right now at SMUD, such as expanding our fiber networks through physical fiber additions, as well as DWDM technology to expand our fiber networks on our substations and campuses. So for that's enabling us to build on our infrastructure. We're constantly growing. We're constantly adding substations and things like that. We're exploring clean energy options. And so having those networks in place has enabled that to move in a much smoother way. We've also been investing heavily in distribution automation. Telecom is the backbone to making DA kick. And so we've been deploying hundreds of DA devices using cellular comms in the field. And that's helping us isolate outages and perform remote switching. For us, that's a win with less truck rolls, less hands on our lines, putting our troubleshooters at risk with manual switching, and being able to isolate outages and switch them back into service really, really quickly. So we're able to respond to outages faster and safer than ever before. We're also using our DA devices to collect data from them to improve our power flow models. So as we expand our DA network, our models are going to continue to improve, along with our ability to respond to those outages faster and in a less manual fashion. So for us, it's a win for reliability, it's a win for performance, safety, customer satisfaction, you name it. There's kind of wins everywhere when we look at these different things that we're investing in.
Yeah, that's great. And I think to just kind of revisit some of the points Adam made is these changes don't happen overnight. It really is an investment. It really is a pretty long timeline on a lot of these things. So glad to hear some of the things happening at SMUD, and we're going to revisit some of those in just a little bit. I do see some questions coming in from the audience, which is awesome, and we're going to jump into those in just a few minutes. But I did want to introduce our third panelist, who brings a lot of telecom experience to bear here today. So Rick Fulweiler leverages 3 decades of technology experience in the telecom industry in his position as Senior Director Product Management at NetScout. He works closely with global customers and strategic partners in AI ops and analytics, 5G, and virtualization. Prior to moving to the project management office, he spent a few years in the chief technology office, where he was repatriated back to the US in 2016. Rick spent 3 years as the vice president of sales for EMEA for Tektronix Communications in the UK. Before that, he served as Tektronix Communications sales director in the Americas in 2006. Before Tektronix, Richard spent 5 years as a director of North American sales for Ixia and 7 years as director of North American sales for Tekelic. I hope I'm pronouncing that correctly. Rick has also held several senior marketing and application engineering leadership roles in the telecom startup space of a company called VIAV Solutions, over the course of 10 years. There's a few acronyms I had not seen before, but Rick, thank you for joining us. You have a very deep background. I know in some of our prep calls, a few times you were talking over my head because you live in this world. So we're really going to lean into your expertise in today's session, if you don't mind. And I would like to open up with a question for you. I'd like to hear your opinion as a telecom engineer. If you were the executive responsible for grid operations and engineering, what is the most important way a utility needs to be managing its telecom networks in this increasingly distributed energy environment? So again, we've heard from Adam kind of at a high level as to why this is important. We've heard from Bree with some very real world examples of what they're doing at SMUD. And now you as the telecom expert with that deep expertise in telecom engineering, what are some things that if you were sitting in that VP of grid operations seat at a utility, what are some things that you need to be doing to ensure that your networks are supporting this energy transition and just sustaining operations?
Sure, appreciate that, Mike. And again, thanks for having myself and NetScout on the panel today. Really appreciate that. So I think one of the things, if we kind of take a step back and we look at some of the reasons why a lot of the utilities are deploying, either an LTE type of network or a 5G network, it's really to support some key tenets. And the key tenets would be real-time latency, like low latency data exchange, and also to accommodate the additional data traffic that's going to go across the network. And I think it's important to understand this new network that's being built is fully embedded into the grid operations. So this is a little bit different. This kind of bucks the trend of trying to treat the network as part of an IT function. It's no longer really kind of a separate IT function, but really a core component into grid overall resilience and also into the operation intelligence of the grid as a whole. And I think it goes back to a little bit of Adam's statement about this is kind of a living, breathing kind of organism kind of thing. I think that's really kind of an important kind of analogy to kind of bring out, and I really like that. So I think, back to your point, is being responsible for grid operations and engineering, I need a system that's monitoring this new network infrastructure all the way from the radio access part of the network back into the mobile packet core. And literally, 24/7, 365, providing real-time availability metrics of the network. And also the key part about this is all the services that are going across the network, such as the IoT devices utilizing SCADA, AMI, emergency de-energizing systems, and so on. And I think Adam also went through a list of a few of those too. So that's real important, all the way down to how well each device is performing that's attaching to the network. In fact, if we kind of go back and look at an example, let's suppose that I'm looking at kind of a real world example of devices communicating to the network, which means are they attaching to the network? Are they authenticating back to the network itself? So when I think about authentication, I also need to think about, are they getting the right, what we call in the telecom network, the quality of service class indicators. And different types of protocols have different types of class indicators based upon the priority of service. Like SCADA has a different one. Some of the other stuff on AMI have different types of class indicators. But if they're not working correctly, as a telecom engineer, I need to know why they're not working correctly. Or if I'm delivering voice-based services, say voice over LTE, what's the quality of service being delivered to each of the handsets that's supporting that voice-based service? If there's issues such as call gaps or one-way audio, what's causing that? And is it affecting a particular market versus a different market? I need to be able to know that. I need to be able to know that in near real time. Or if I'm having devices that are dropping off the network, is it because of the radio access network coverage issues? Or is it really frequency interference? And this happens all the time to where we have our friendly neighborhood public network overshooting a little bit into our area and causing interference, and that interference is actually causing devices to drop off the network. And something that's also kind of dear and near to us is cybersecurity, is also really a major trend, especially now in today's kind of climate. Are devices compromised? Are they generating denial of service attacks either toward the infrastructure itself, or are they generating denial of service attacks toward the applications that are running back under my hosted network? So I need to be able to identify them as quickly as possible and also mitigate that. So at the end of the day, those kinds of things would definitely be at the top of my mind as a VP of Network Operations.
Okay, that's great. And there's one kind of follow-up question I wanted to ask you. As you were describing having these low latency networks that can accommodate massive amounts of data traffic. I know one thing we spoke in some of our previous discussions was how the network needs to be able to set priorities with different types of network traffic. Because obviously some data is going to be more important or more timely than others. Can you speak to that a little bit in terms of what you're doing in your organization at NetScout, or just maybe in general even, this idea around setting priorities in network traffic and how that's important when you have all these different business functions and applications moving across a network?
Yeah, I think it goes back to understanding how that prioritization is set. I mean, if we look at it from a telecom perspective, and we touched on this a little bit in the previous question, there's this thing called QoS class indicator. So this is how the priority is set on anything that attaches to the network. Different types of components attached to the network have different levels of priority. All this is part of the PCRF if you're in a 4G network, or PCF if you're in a 5G network. So whenever a device, be it an IoT device, be it a handset, be it anything that attaches to the network, it's automatically assigned a class indicator. And if the class indicator isn't set properly, then you're going to see multiple different types of issues. Those issues could be all of a sudden I'm getting lots and lots of packet error loss, and it's exceeding some particular type of threshold. The nice thing about it is that as I'm monitoring the network, I'm also monitoring not only just the data that's going across, but what type of data is it? Is it AMI data? Is it SCADA data? Is it voice data? And I know in the side of the system, I can set, what is the thresholds for packet loss? What is the class indicator should be? And if it's not set properly, automatically that's going to be able to generate an alert. That's going to go back to operations, go back to engineering. Why is that done? What caused the problem? And that's what I'm going to be able to look into. And I think, as we kind of look into the future a little bit, I think that's also going to start calling out for kind of a chat LLM kind of interface to where it can automatically detect this threshold crossing. It can then go back and look at, was a change made in the network? Did somebody change or update the software back to my PCF or PCRF? Could that possibly change the clause policies set into the network? And if it did, you can have the capability to do some automatic orchestration to where I can actually have the LM go off and actually communicate back to an orchestration system to actually be able to fix that. I think that's what we're going to see as a more dynamic kind of network, where we have this kind of human-machine interface driven through some AI interface.
Right, and I think part of what I'm taking away as you were describing that is, if you look at a utilities network or networks plural over pick a period of time, 10 years, even 5 years, all these new use cases are continuing to evolve, and that prioritization of data across the network, I think, is going to just increase in importance. So I think that's something for all of us to keep an eye on. But great opener, Rick. Thank you. I do want to jump over to an audience question, or actually there's a part A and a part B to this question, and I'm opening this up to the entire panel because it's pretty interesting. What about using FM radio band for utility communications for distributed energy resources? And part B would be to include EV chargers. So any thoughts on using FM radio band for these types of use cases?
I think, from our perspective, working at it from a telecom kind of viewpoint, there's a lot of concerns with, I think, interference, and especially with FM. I mean, right now today, you're seeing a lot of the CBRS and 900 megahertz being used for LTE, and also being used for 5G, and there's some other bands that they're also starting to look at too, which are cleared. And not only are they clear, but they also understand the model propagation of those particular bands, which is real important. So whenever utility goes out and wants to decide on a particular area they're going to be deploying CBRS, they need to make sure that the model propagation is working. So that means that the signal noise ratio of the floor is correct for that particular area. Then I'm getting the right power back to the handsets, whether it's on the uplink or downlink side. So there's a lot that goes into this, because the key part of this is when a utility goes down this path, they're basically a mini carrier. So everything that a normal carrier would go through is exactly what a utility would go through. And I think that's a key thing to keep in mind.
Yeah, I'm on the board of the Utility Broadband Alliance, and we talk all the time about, really a lot of what we're doing is helping utilities figure out how to leverage cellular communications for the most part, and there's a large focus on private cellular these days. And even within that, you look at a spectrum that's cleared like CBRS, but people can use it. It is open. You have to use a SAST in order to manage it, and so there are sort of there are governance measures in order to make sure that traffic can be controlled and that you avoid obstruction on the network. You still talk to a lot of utilities and they say, I don't want to build my 10 to 20 year telecom strategy based on unlicensed spectrum, because I don't want a change in how that spectrum is used down the road to result in a cluttered spectrum environment that then reduces my resilience. So thinking about that 5, 10, 20 year timeline, knowing we have no idea, we have no ability to predict how cellular usage will evolve over that time, I think we're seeing a huge preference towards having licensed spectrum, or working with those who do, like the carriers, and having things like preference and in the traffic, right? How do we get that protection, which you don't get on FM? I don't know that there's one size fits all to any of this, but I think that that's going to be a huge concern about using that technology.
Yeah, and Bree, I
Yeah,
see
and
you
just
nodding. Yeah, jump in, please.
yeah, just one other thing to add. We've been looking into private LTE and things like that. With FM2, it depends also just on the terrain in which you're operating. For us, we have valley and we also have mountains. And so we have to look at, kind of what's going to give us the best connectivity based on our terrain. And private LTE too it's an option, but it can be cost prohibitive. And you might have to add additional infrastructure that could be really costly. So,
A lot of variables. Yeah, good. Well, thank you, audience, for that question. That was great. Adam, I do want to come back to you, and I want to kind of talk a little bit more about not just about the network itself, but one of the things we've all talked about in the run-up to today's session and our various prep calls is this idea around network visibility. And again, I think much like we've discussed in this first half hour of our session today, I think there is a little bit of a check the box. We've got our network boxes checked. Let's go do stuff. I think that if we hit pause for a minute and think about this in terms of managing that network more proactively and having that network visibility, I think there's a lot of opportunities there for doing things not only to ensure that reliability, performance, and safety, but also maybe even be predictive in some cases. So what are you seeing when you're working with your utilities, utility customers? Because I know of a few you've worked with real recently. Where are they seeing that network visibility improvement or capability being applied to really impact how well they're operating?
I think everything that utilities are doing in order to digitize, and I mean, you listen to a lot of what Bree talked about, there's all of these use cases that are coming out that in order to drive that reliability and resilience into the grid, but none of that works, right? No one would have adopted Uber if the network was unreliable and you couldn't reliably connect to those, right? We've all been for anyone who's been in technology, getting adoption by the line of business of anything, if it's unreliable or if it's spotty or it doesn't work when they pull it up, it's one, it's always the network's fault, but two, they just won't use it, right? The way that it's always been done is the easy answer. And I think we're in a position right now where the way it's always been done is not applicable to the future grid. It cannot be done the way it's always been done. So it's critical that we figure out a way to make sure that these foundational technologies can support these new use cases as they go out. You can't possibly have reliability and resilience of a network if you don't have visibility. So it starts with it's everything that lives on that network requires that visibility. Then you get into the more nuanced approach of something like QoS and being able to control what traffic comes through and what traffic gets held back when resilience or bandwidth is constrained. But that's something that you can only do if you actually know what's on there and you have control over that network. So I think we're going to have to get, I think about all of the fiber networks that were deployed when people said, oh, we'll never need more than 6 or 12 strands, but we're going to deploy 144 or 432, and we're going to create a whole side business about it and lease it out, and it's going to be great. Now people are worried that might not be enough fiber for them to use over time, and they're looking to potentially expand that as they put out more conduit. So it's the amount of need for that bandwidth and that network is growing exponentially, and with it the requirement of resilience. And again, you can't get resilience without visibility.
Thank you for that, Adam. And I wrote a question down here as Rick was making some of his opening remarks, and I want to ask actually the entire panel this. Rick, I think I want to start with you, but I think Adam, some of what you said may rest on this as well. Rick, when you were making your comments, you talked a lot about being able to diagnose issues, and I know we've talked a lot about analytics and predictive nature of things that we're moving towards. So I'm wondering if the panel, particularly as we start thinking in terms of that improved network visibility, can speak to diagnosing versus maybe predicting different telecom issues. I know that some of the capabilities exist, and I would love to hear a little bit more granular detail on what that looks like. In my world as a utility guy, I can think a lot about predicting failure of transmissions or predicting customer behavior based on payment history. So there's a lot of interesting predictive examples in the space, but drilling down more specifically to that network, where is predictive versus diagnosing after the fact maybe something that we can start looking to leverage when we think about network visibility? And I'll open that up to the floor.
I mean, we're working with a number of utilities on what we call AI ops, but AI ops and AI enabled operations is what that stands for, and it is the future. It's coming. We have to have it in order to drive this resiliency. You need to get to the point where the network is to some extent self-healing and can predict that failure and diagnose itself and take action based on the data that's coming in. Again, the foundation for all of that is visibility. It starts with the dashboards that people have that show them what's actually happening on the network, and taking the war rooms that come every week and turning it into a once a month, once a quarter, once a year event, slimming down the list of people because you can automatically say, this is not, here are the 10 groups that are involved in an outage. This is not these 9, it's this one that's the problem right now. So it starts with that responsive, the responsive nature of operations. But as we get enough data, we look at something like ChatGPT and LLMs were trained on this unlimited amount of data on the internet, and we are just gathering that data, this visibility by implementing the right level of visibility. You're getting that granular data about what's going on the network that over time can then tell you what to expect and when to expect it in a way that allows you to automate out of outages before they happen. But it can't. That is an evolution. It's not something that you just implement on day one. I know, Bree, I would love you run operations for telecommunications at SMUD. What's your thought on it?
Well, so AI is something that we're constantly thinking about how we want to implement, but we only have a couple systems that are using anything kind of like it at this time. We're still a little bit manual when it comes to, identifying outages, looking at our systems, and responding to those. But I think you're on the right path. I think that we're going to need it. We're going to need AI because these networks are just getting bigger and bigger and more complex. And unless we're going to have an army of telecom techs at every utility, we're going to need to find solutions to address those in advance. And like you said, maybe even self-healing, or at least something that's going to alert us to that. One thing that we're looking into is just asset analytics for our telecom assets. Kind of just systems that we can use that give us an indication that something is wrong before we go out and perform an inspection. We're very manual on that. We're going out to each site, taking inventory, running diagnostics. We want something that's going to take all that information, aggregate it, and tell us, hey, this looks like it's going to fail in 6 months to a year, and address it in advance. Preventative maintenance is almost always cheaper than corrective. So, anything that we can do to drive that's going to make us more reliable, and it's going to make us a better utility.
Wow. I want to come back to the asset analytics for telecom assets a little later, Bree, because that's an area of interest for all of us, I think. While we're on this topic, Rick, can you talk a little bit about what does this look like? I mean, conceptually, we understand you may have network failures. You may be able to diagnose these. You may be able to predict these. Can you just talk a little bit more what that looks like, if I'm either in a control center or if I'm a telecom manager like Bree, what does that look like for folks that, getting that improved network visibility, being able to be more predictive rather than reactive? What does that look like?
Yeah, well, I think it looks like a couple different things. And I think it goes down kind of two major paths. And one of the paths that Adam kind of spoke about is the AI ops engine. I mean, obviously that's that's a very important path, because at the end of the day, when you start this visibility, right, this 24/7, 365 level of visibility, you're looking at everything that's going across the network. You're looking at not only just the devices, how well they're performing, but you're looking at what are the patterns, what are the patterns per individual market. You're looking at all the data. And now that I'm looking at all this data, it's a wealth of information. It literally is kind of the gold inside of the utility. And that information can obviously be fed into an AIOps engine. So that can actually start driving things like predictive analytics. And there's tons and tons of other potential use cases that we could possibly see a utility to have. And one of the first things that I think is the importance of, from a troubleshooting perspective, okay, I think this is great. I got all this information. Maybe the monitoring system is also doing its own level of kind of higher level AI and ML, but I want to front into it. I think it's, to Bree's point, I want to kind of reduce the amount of human effort required to be able to support this very large, breathing, very complex network. So I think the first thing is that, putting in an LLM as kind of the front end, but putting in a local RAG that understands only the data that's inside of that particular utilities network. Keep in mind, what Adam was saying is that you see a lot of LLMs, but they're trained on internet traffic, right? They need to not be trained on internet traffic. They need to be trained on utility traffic that's only going across my network. They need to be self-contained. Need to be inside of their own bubble. And then once they're inside of their own bubble, you can put an RAG behind that only understands the network level traffic for that particular utility. And that's so important. You have that kind of self-contained bubble. From there, you can do kind of really cool things. You can do kind of this self-diagnostics process. You can say, hey, show me the class indicator of this, or show me this. Why is this problem happening in my network? So you have this kind of interactive chatbot you can start talking to. I think it's also going to start driving, other things as we go forward. We're looking at how well devices attach. We're looking at IoT devices. We're looking at more sensors being deployed onto the distributed energy resources. And now we kind of can have this kind of AI-driven grid operations. I think it's going to play a very central role in predicting demands, balancing supply, managing anomalies in real time. And I think it's also going to probably have some type of maybe level of monetization, because I think, if the utility starts looking at other revenue streams, I think this grid data can also be monetized. For example, it gives you tons of insights into, you're looking at the entire electrical grid of an EV infrastructure. That's important information, I think, that other companies is going to want to leverage. Smart cities, urban planning, things like that. So I think there's going to be other outside demand for this information, not only internal to the utility, but also externally too.
Yeah, and
wow.
I want to give an example. Rick brought up or something I saw at a utility that I think ties to something Rick and Bree were speaking about, which is, I think there's visibility, which is there's having the data, and then there's visibility, right? You can have all of this. So I was talking to a utility a couple of months ago, and somebody from the operations center said they spent their weekend sifting through 800,000 lines of logs to find the 5 lines that caused an outage that dozens of people were online trying to figure out over the weekend. And that is both it's a very slow reaction time. You're burning out your people. You're not getting, that person's an architect. They should not be spending their time digging through logs. And even accessing that information can be a whole process into itself. So something like what Rick is talking about, the tools using LLMs and RAGs, and even looking at something like being able to ask the system, can you share with me an anomaly in the logs? Now tell me, it looks like it's this type of error. What, can you pull from the manual? What am I supposed to do in that situation? It could be a training for the next time something like this happens, but you can also have the system look all of that up and suggest to you, or even take that action automatically of how to clear it. So the potential for driving reliability and resilience into these networks and the infrastructure is incredible using the technology, But again, you need to have those. If those logs don't exist, you can't do anything. And then you have to layer these capabilities and technologies on top, both from a technical competence standpoint, but also an organizational readiness and sort of willingness to trust standpoint as well.
Right. Yeah, I wouldn't want to spend my weekend doing that either. I want to spend just a minute with you, Rick, and then I want to get back to Bree on that asset analytics point that she made. Comment and a question, Rick. The first comment is, you said the AI ops engine looks at all of the data. That's mind-boggling. That's my comment, because the volume and the speed and the scale is just crazy. And then the second thing I had was a question. I thought I knew most acronyms in the utility industry, but what is RAG? That's a new one for me.
So, well, RAG is not exactly a utility industry name, so it's actually more in the AI world. So it's retrieval augmented generation is what it is. So its ability for the LLM to communicate to kind of a second level of data. So the RAG could have a kind of proprietary interface to localized data. And that localized data would be the data that's sitting there inside of the utility. I mean, potentially the LLM could communicate to external information, but generally, because of the firewalls and things like that, you're probably going to have the LLM only communicating to the data that that's present inside of the utility. And keep in mind, when we talk about data, we're taking kind of the next level above log information. We're looking at, in a telecom network, we're looking at the 3GPP signaling information, and you're looking at the user plane information. So you're looking at, how well are the internal infrastructure, the devices that is making this network work, function. Are they healthy? Are they working properly? Is the communication between that infrastructure working properly in my packet core? And we talk about the user plane, we're talking about the data, whether it's AMI data, whether it's SCADA data that's going across the network, and we're monitoring that data. Is there packet loss? Is there latency? Is the QoS policy set correctly? Am I having congestion in a particular area? If I am, why is that congestion taking place? Keep in mind that when you're pulling out, whether you're pulling out Wi-Fi, you're pulling out, say, a traditional wired network, and you're putting in a telecom network, you have to make sure that the telecom network is working properly too, along with everything that's going across that, right? And that's really key.
Okay. All right. Thank you. A lot going on there. Bree, I do want to come back to you. When I heard you say asset analytics for your telecom assets, I wrote that down right away, because I would like to learn, and I think our audience would as well, learn a little bit more about, again, what does that look like? I know what an asset management program looks like for a transformer fleet, or equipment inside a substation, or poles. But tell us a little about what you're doing on the telecom asset side of things, and how much you're relying on data versus crews in the field, and just a little bit of what that looks like.
Yeah, so asset analytics is something that we are trying to develop right now in kind of a more intelligent manner than what we've been doing in the past. Currently, the way it looks is we have preventative maintenance inspections that we send our telecom technicians out to do. They provide us with the information, and we make decisions based on that preventative maintenance. And then, of course, if we have outages, things like that. So it's very reactive, right? Mm-hmm. But what we're wanting to do is move away from that. We want to get to a point where we can aggregate data from our preventative maintenance inspections, from those corrective maintenance truck rolls that we have on different systems, collecting, all the data that Rick was talking about, from SCADA and, OMS, anything like that, aggregating that information to say, something's not right here. We need to investigate, and let's do it proactively instead of in a reactive manner. That's obviously very complex, and we're kind of still looking at what are the industry best practices. Are there tools out there that can help us with this? Or do we need to look at developing something in-house? And so we're kind of on that journey right now, in the midst of a project, to see if there's anything out there that could help us with that, instead of making those manual decisions.
Okay, that's interesting. I had a couple quick comments. One is, Adam, since you're on the board of the UBBA, I think Bree just volunteered to present a session on telecom asset analytics at your next conference.
I took a note. Yeah.
But also, I find it interesting that you're combining all these traditionally disparate data sources and trying to make sense of those. So I think we're going to want to track that and follow that, because if you all are able to get progress in that space, I think that's a big leap forward for our industry, because we're swimming in data, right? But being able to take a leap like what you just described, I think is pretty significant for us. So thanks for bringing that up.
And if you add to that what Bree's talking about, when you look at, and I heard a little bit from Bree and a little bit from Rick, now when there's a network outage or when the communication goes down to an endpoint, it can be the cellular device. If you have your private cellular network, it can be the radio access network, it could be the core, it could be the fiber network and the transport back. It could be the endpoint itself. It could be, so the number of pieces that you have to monitor as the owner of the system and as the operator of the grid, and the grid now includes communications. They are inseparable. Right? I think it was John Hughes who coined the phrase 10 years ago or so that the network is the third grid, and it really is. It's even going back to teleprotection, right? If teleprotection goes down, you got to shut off power. We're getting to the point where more and more, as we stop building our generation, transmission, and distribution to meet peak load and instead look for ways to curb it, if the systems that allow you to curb peak load go down, you no longer have a safe grid to run, and without that control, that's the world we have to go to. So we're getting to the point where the more and more of these communications networks are critical to running the grid and having power to homes, businesses, and public safety. And so the networks need to reflect that, and the ability to run them reliably and resiliently needs to reflect that as well.
Yeah, and it's that, we've been having the IT/OT discussion as an industry for a decade or so, and I think this is a classic example of it. Just one kind of side note / data point. We're doing a research project here at Utility 2030, and I interviewed a CIO yesterday, and he was talking all about ADMS and EMS and DERMS, and I put my hand up and I said, well, that sounds like that's all operational stuff. He said, yeah. At some point, it was a year or two ago, he said, yeah, we moved all that into the CIO shop because it is so dependent on things like the IT infrastructure, like the networks. So I think that whole IT/OT space is merging, like we've been talking about, and these are some great examples here today. And again, it's technical, it's organizational, it's data, it's all that stuff. Rick, I want to come back to you, and we've talked a lot about some of the different things going on around the network and how that's foundational, and we've talked about some use cases, but speaking just specifically to that network visibility concept that we're kind of honing in on here today, from where you sit as a really deep telecom engineering guy now working with utilities, what are some benefits of having that improved network visibility that, again, if you're a VP of grid ops, if you're a CIO, what are those top 2 or 3 things just like, man, we got to get on top of this?
Well, I think in general, it goes back to really a faster fault detection, resolution of issues. I mean, that's really the critical thing that you want to do. Being able to pinpoint faults, congestion points, service degradation, troubleshooting becomes much more faster and minimizes downtime. And I think it goes back to Bree's comment about people spending the weekend, or people looking at all these trace files and log files. I mean, why? I mean, there's so much technology out there today. Being able to leverage multiple different types of technology to be able to do what humans find almost impossible to do. And we really see this problem amplify itself, and especially coming from the traditional telecom side, that this has been out there for years. I'm having call drops or gaps in voice calls or one-way audio in a particular area, and it takes a RAN engineer, it takes a core engineer, it takes a VoLTE engineer. I mean, to your point, it takes a lot of different people from different types of disparate disciplines to come together to try to solve these problems, to where a lot of this information is driving, whether it's driving more an AIOps engine or whether it's driving, its own intelligent AI and ML environment. We can actually do a lot of this automation automatically for the customer. I think that's going to be really key, and then that's going to drive problem solving. And there's so much of that. For example, if I'm seeing devices starting to drop off the network, why are they dropping off? Is it related to a problem with my packet core software? Did somebody do an install? Did somebody upgrade something in the packet core that's causing this to happen? Or is it the fact that I have a problem with my coverage now on my radio access part of the network? Well, one of the things you need to be able to detect that, right? You need to understand, what the problem is. Is it a RAN problem on the coverage side, or is it interference, or is it maybe related back to my packet core? I don't know. I need disciplines in both areas to be able to figure that out. I mean, case in point, we had a customer that says, all of a sudden I saw devices starting to drop off, and I did some deeper analysis with this particular tool, and I found out it was actually related to a coverage problem. And you would think, well, why would you have a coverage problem? Because this is kind of fixed devices. It's not like they're moving around, right? Well, the problem was that they were building this huge apartment complex right next to the substation, and all of a sudden, it was actually blocking part of the signal, right? So they're just right on the fringe. Your devices are attaching and dropping, right? So, but we're picking it up. We're picking up power information coming off of the E node Bs and saying, oh, it's not in the right tolerance, so something's going on in that particular area, right? And this is a great case to be able to isolate those problems very quickly and being able to see that near real-time information.
I'm keeping some notes here. You start off by saying faster fault detection and resolution of issues, and I think we all would add to that even the predictive identification of these issues. Let me ask you a corollary to what we're talking about right now about these benefits. The short version of my question is, who gets it? And the longer version of the question is, when you're inside of a utility, and this is for all of you, and Bree, you can give your perspectives, and Rick and Adam as they look into and work into and with utilities. When I say who gets it, in other words, are the folks on the operations side of the house running the grid, et cetera, are they like, we're focused on the use cases, we're focused on all this equipment that we have to maintain and operate to keep the lights on? Those IT guys down the hall, they better be taking care of our network. So if you come in with a message around network visibility, for instance, where is that resonating and why? I want to just kind of continue that IT/OT discussion, because I think we're on the brink of bridging that gap. I think this is an important part of that. So where are you all seeing that opportunity or that recognition of, okay, network visibility is going to help me execute on my mission more effectively?
Yeah, I mean, in our shop, there's not a real clear line. We're telecom operations, and so we're on the energy delivery side of the house, but our closest partner is Operation Technology Group. And we work with them every single day. There's not always a clear line on where we start and where they, where we stop and where they begin. It's a true partnership, and it's something that we wouldn't be able to function without. And so, for my team, they're go-getters. They want to make sure that everything is working. They'll do what they can to diagnose what they can, and then they'll tag it an engineer as soon as they've hit a roadblock. But for us, there's not a clear line, and I don't really see that it's going to get any clearer anytime soon.
I think that, as we've seen utilities sort of engage and start to blend these two groups and invest in the digital technologies to enable that, for a little while there was this concern that we're replacing OT truck rolls with IT truck rolls. Instead of going to fix the transformer, you're having to go fix a router that is monitoring the transformer because now you don't have the visibility that you thought that you had invested in. And so it's getting that resiliency right through visibility and having the right visibility to be able to diagnose issues. Some of these times you don't need to go fix it immediately. You can prioritize it, just like you can prioritize traffic, you can prioritize the work orders, but you can also do that in a way where you're giving confidence to the business that, hey, we've got resilience and we've got redundancy in some situations, so we can still monitor what you're doing and or enable you to monitor what you're doing so that the grid is safe, even if we don't temporarily have all of the resilience that we had before. And we're hearing things like predictive maintenance. I think for many years that's been a phrase that really only applied to the heavy metal assets. Now, because the grid, it's a sign of the criticality of the networks that we're talking about predictive maintenance of the network assets. And
right.
It's because it's critical and we can't do this without that. And so that's I think in itself a microcosm of everything we're talking about here, and the criticality of it, but then the importance of the downstream importance of having that visibility and that integrated view across all these different sources of visibility to all of your assets and the network as a whole.
Okay, thank you for that, Adam. And I think that does help kind of paint the picture a little bit. Bree, I do want to go back to you. You used the term your operations technology group. So by the very nature of that, that sounds like that rolls up to the COO, not the CIO, correct?
No,
Okay.
they are they're under our CIO.
Okay.
So yeah, my group operations, we follow under the COO. So there is a divide there. We've actually, there's been times where we've been under the same umbrella and they've pulled us apart. That's how tricky it is,
Yeah. Yeah. Okay. That's helpful. And again, I think that just contributes to how the heck do we organize to really take full advantage of these big network investments, these massive smart grid investments. And you're kind of center of the storm there, Bree. So I think we're going to want to watch how things develop in your role and your organization there at SMUD. And actually, while I've got you, we've talked a lot about some different pieces of where the value comes in, what those use cases may look like. But Bree, I did want to come back to you. Is there anything that leaps out at you? You talked about laying new fiber, cellular communications for your DA, and how you're using DA for power flow, et cetera. Are there any other specific use case where you can say, that telecom network is really enabling that? Are there things on the customer side as you start looking at, again, distributed energy resources and your 650,000 customers? What's maybe a use case or two that you can share where that network is really the enabler?
Yeah, the biggest one that comes to mind, and I know it's one of your favorite topics, Mike, is the AMI 2.0 transition.
Yes.
So we're in the midst of that right now. We're in phase 1 of that. And, our meters were at end of life. We were looking for a solution that could incorporate DERs. So the devices that we selected are going to give us a much more detailed look into how our customers are using their power. We're going from 15-minute snapshots to 5-minute snapshots, which is giving us a better look at their power consumption. And it's giving us a clear picture of the DERs our customers may have in place and help us better manage those. As Adam has said over and over again, none of that works without the communications being in place. And these devices, they're packed with functionality that we know can help us with issues in advance, give us that kind of indicator that something's happening, instead of waiting for, a customer complaint or trying to make generalized predictions. A couple of the things that come to mind that's really going to help us out once we get this fully in is like high impedance detection. It can kind of see if there's poor power quality, so we can be more proactive, instead of a customer calling us and saying, hey, my lights are flickering. We should know that in advance that we need to go and address that. There's also some benefits to the utility, like meter bypass detection, so that we can address power theft. This is obviously, not just only a revenue concern, but it's a safety concern. It's a safety concern for the customer who's doing it. It's a safety concern for the meter tech that's going out and trying to address it. So being able to see that without having to go there initially, that's a great indicator for us. Also, it's these the new AMI meters that we're looking at, they are much more refined when it comes to location awareness. We currently log this manually. So we go meter 1, 2, 3 is here, meter 4, 5, 6 is here. And then if something is off, we have to send somebody out to the field to verify that. But this is going to now give us this real-time ability to ping it and look at it, and it's through that connectivity. So it's going to save us a lot of time in the field. And it's also they're going to give us a better idea of the near real-time monitoring of transformer loads. So we can know if something is getting overloaded. And it's a benefit to the customer too, because they integrate DERs. You know, if somebody has solar on their house right now, we have a separate PV meter that has to get installed for them. With this, it's one meter, it's something that we're providing. So it's a savings to the customer too.
Okay. Well, those are great. That was a great list. Holy cow. Yeah, the transformer monitoring piece is pretty interesting. I know that that's something that's been bubbling up in our industry for some time. And there's a lot of innovation around using different data sets to do that, not only monitoring, but also predictive maintenance applications on those transformer fleets. So in an industry that's historically been run to failure on a lot of those assets, I think there's some opportunities there for, again, for performance and reliability and safety improvements, economically so. Did I cut somebody off?
I was just saying, I'll add one to that, which is we don't have enough transformers to meet the load requirements that we need with all of the AI data centers coming online, the EVs being added online.
Yeah.
We cannot possibly make enough in order to meet these demands. We need to use those transformers more efficiently and effectively, and we can't do that if we don't know what's on them and the level to which they're being used and the environments that they're in. You know, on a cold day, you can use it more than on a hot day, and but you have to really know the microclimate to know what's actually happening right around that asset, and how's it been used over the last, you know, hours, weeks, months, and so forth. So I think that's another area where it's another meter, but that meter is now going to capture all sorts of granular data. And even if we're reading it every 5 minutes as opposed to 15, the amount of data coming off of it is so much different each time you read it that the network has to be rethought. And again, it goes back to that, if the use case is real time or near real time or even every few minutes, you know, it's not, hey, that meter's down today, we'll try to reread it tomorrow so that we can get a bill out. It's that if that meter's down today, we don't know what the load is from that house. And if that happens with 10% of the homes, and say 50% of those have EVs, we don't really know what's happening to that transformer. So we need to solve those network problems much faster, and we need to be able to do it remotely. And it goes back to starts with visibility.
Right. Yeah, and that landscape, to your point, Adam, is changing really quickly, and the rate of change isn't slowing down, not the least of which is because of the demands that we're seeing come online with electrification and data centers, et cetera. Man, so you're anticipating one of my final questions, and I am keeping an eye on the clock, and I did have a couple questions I wanted to ask you all as we move towards wrapping up. The first one, and this is for the entire panel, is, you know, we all work in utilities. All of us have been doing it for years, even decades in some cases. As an industry, we tend to get excited about new technology, right? I can remember when smart grid was a buzzword. I can remember when outage management systems first came online in the late 90s. So we tend to get excited about technology in our industry just as a general rule. But taking that beyond just the, hey, this is cool new stuff, and we've talked about some great use cases, I wanted to see if this panel can maybe draw out a little bit more of the business value as we start looking at these investments in telecom, this network visibility proposition and the value therein. Maybe speak a little bit more to business value. And again, I can see Bree sharing experiences at SMUD, Adam, and Rick, some of the experiences you've had working with your customers. Where are you seeing this really land in terms of business value?
I think one of the things that we touched on just kind of briefly is I think potentially with all this data, it could look like a new revenue stream, as I said before, for monetization of the grid performance data. As I said, it's providing tons and tons of valuable insights into a variety of different industries, such as the EV infrastructure. Bree talked about, smart meters 2.0, smart cities, new urban planning. How am I going to start planning, kind of the smart city of tomorrow? And I think this data is valuable outside of just the utility. I mean, I'm sure there's tons of monetization use cases utility could start thinking about outside of the box. They could probably even start their own group about, hey, how do I resell this data? How do I make it available to other industries out there?
Yeah, and as you were going through kind of the list of possibilities there, one thought that occurs to me is utilities all have these large commercial and industrial customers where power quality and reliability are huge. And I could see this being a part of that value proposition to these large customers where it's, again, it becomes like a new business. It's interesting.
Yes.
Okay.
Mm-hmm.
Well, and as the grid, as we need more DERs and more private generation in order to meet the peak demand, and we see these power purchase agreements happening where large companies are working with generation companies to meet their requirements, advising them, using this data to advise them on when to use what load is really going to be incredibly valuable and necessary as we all evolve. And I think companies will have to pay attention closer and closer to their power bill, but also just usage overall. And reliability. I think we've just never lived in a world in this country, for the most part, that where power availability was an issue. Cost may be an issue, but it was reliably available. And I think we can all see a time where we see the power purchase agreements by private companies because they don't believe they can get what they need from the traditional grid over the next 5, 10, 15, 20 years. So it's I think that in itself is a sign of the information that normal people and companies are going to need in order to make these decisions about how to power their operations.
That you brought up the PPAs. It's not a big leap to see a utility's growing reliance on power purchase agreements and making sure they have the infrastructure in place to properly manage and deploy and maintain all of those systems that are now connected to their grid. So yeah, that's a really good example, Adam. Thanks.
Well, and we're seeing signs of it. You see the subsidies to get Tesla power packs in Southern California. You see the flat charging rates by folks like Duke Energy for if you let them decide when your vehicle charges at night, they'll give you flat fee for charging. Those are programs that are not too dissimilar from this, but again, you need that connectivity to those assets in order to control and curb that demand or optimize that supply and demand curve.
These are good examples. All right. Bree, did you have anything?
The only thing I was thinking about too is just from an operational perspective, if we're collecting all this data, as long as we're doing something smart with it, being proactive, that's going to be a cost savings for the utility. Something blowing up is always going to cost more than replacing, a part or a component. And the other thing too is I always have safety front of mind. And so if we're reducing our truck rolls, doing less manual inspections, that's an improvement to safety. And all of these things come down as cost savings, which could eventually trickle down to the ratepayer.
Right. Rate stability is key in this changing environment for sure. Okay, I'm going to ask the closing question. It's kind of a big one, and I call it my crystal ball question. So whenever I have an opportunity to speak to smart people in a session like this, I always like to think about, okay, this is all great stuff. We're in a very dynamic environment today, but what the heck is this going to look like a few years from now? So as we start thinking about this, and today's discussion, obviously the focal point has been networks, and more specifically that improved visibility in those networks and the business value therein and the use cases it supports, etc. What do you think this is going to look like when we look out a few years, maybe 5 years, which bring us to 2030? Are there new use cases? We've touched on that a little bit. Where is there maybe new business value? Heck, the operating model for a utility is changing today. So a little unfair for me to ask you all to prognosticate, but I would love to hear your thoughts on this because it meets with business imperatives, it meets with technology, there's an organizational component to it, gets into a lot of interesting things around data. So I'm going to open it up and ask each of you to maybe just share a few things that you're seeing in your crystal ball. Who wants to go first?
I'll start.
Right.
For me, it's that two-way transactional grid with our customers. That's the one I really see us going towards. Customers, they ultimately want like safe, affordable, reliable power. And your utility isn't something you think much about unless your bill is really high or your service is out.
Right.
We're in this day and age where people can get fast food delivered to them without leaving their couch, or a car delivered to their house in a couple of days. I think customers are going to be expecting more from us, and that demand is just going to keep increasing. I think customers are also going to want to have more information about how to manage their power, how to save on bills. For example, if they're integrating solar or battery to their home, they're going to want to know how to maximize that benefit, whether it's to power their own home or sell it back to us. So how can we provide that information to them? How can we influence behaviors to also support it? And if they're electrifying their homes and vehicles, they're expecting that we are going to have that load to meet that demand. So we're going to need to get creative in how we can do that as these use cases increase throughout our territories. For example, we have programs now where we can influence customer behavior by sending a push notification about pre-cooling your home when it's really hot. And that helps reduce strain on the grid. But could we do things like have permission to adjust their thermostats through a smart Nest or something like that? We've been playing with that, and it's in its infancy, but I think it's going to grow. One thing, for example, we're looking into is partnering with EV companies. And I know Rick mentioned kind of orchestrating throughout the grid. Can we identify a block that has 30 EVs, get the customer's charging requirements, and have our system automatically orchestrate charging overnight so that the customers have the charge they need and we have the load available on the grid? And all that requires robust communication systems. It's fiber, it's AMI 2.0, it's robust cellular networks, the list goes on.
Those are great, Bree, and especially I think what's kind of interesting is those applications on the other side of the meter, on the customer side of the meter. I think, I just think about some of my friends here in the SMUD service territory. I think some people would embrace it. Other people would like, no, that's too close to Big Brother. So I think there's going to be a lot of social dynamics around that, as well as just purely the technology. So those are great crystal ball insights, Bree. How about you, Rick or Adam?
So I think, I'm sorry, Adam. So I think Bree really hit on a really key fact. I think having that bi-directional communication is going to be important. And I know that, there's a lot of people that get really worried, to your point, Mike, about Big Brother taking over. But I think, as we look at more of an AI-driven grid operations, I think that's going to really be critical. That people are going to have to say, if I want a lower power bill, or I want a lower utility bill, I need to have this kind of bi-directional communication to where you can start looking at predicting demand, predicting supply based upon usage, to where dynamically I can communicate back to my car. My car is going to turn off because the grid is a little overloaded. Supply is actually low right now. Now dynamically I'll turn it on, say at 3 o'clock in the morning, start charging my car, knowing that I need the car by, say, 7 a.m. So I think the grid and the whole infrastructure has to get a lot smarter. But to do that, you need to understand usage patterns. You need to understand what people are doing in a particular location. And I think that this bi-directional communication, the more the AI engine learns what's going on, not only with the grid and the operations, but with consumer patterns, with business patterns, the more it can kind of have that dynamic elasticity, that kind of command control kind of environment.
Yeah, I mean, I think we're talking about the future of operating the grid and the networks and getting into predictive maintenance of individual assets. I think predictive grid operations is where we need to get to, where we know what's coming and we can adjust the way the grid is being used and those assets are being used to optimize the output for the affordability, the safety, the reliability, the security. And so I think we will, in the next 5 years, take a meaningful step in that direction. Part of it will be AMI 2.0, putting out those devices. But I think about those, going back to the digital nervous system and the Uber example from the beginning, we in 2007, an iPhone was not super the use cases were not as built out, and part of that was just time and development and investment, but part of it was that a 3G network with that kind of device doesn't enable you to do everything that you need to do. A mesh network with a 1,000 meters per takeout point per cellular device, it is not going to enable you to do the kind of things that we're talking about here. So it's an investment in this kind of technology to build that foundational network that allows you to then leverage those receptors, those edge devices to the full extent of their potential. And I think we're going to seed the environment with these devices, these AMI 2.0 devices. I think we'll be seeding we'll be laying the foundational platform of the network with a lot of folks going to private cellular or working with carriers to be more resilient and more affordable. And I think that'll, 5 years is not that long of a time in the utility space. So we think 2030 is really far off, but you think about some of these utilities have millions of meters to go deploy. That's not going to happen in the next couple of years. So we'll be on our way to deploying those networks and those receptors, these platforms of receptors and nerves that will then we'll really be building out the cognition side of that, the applications, leveraging those insights as we get the receptors and nerves, those devices and the networks really formidable.
Boy, good stuff, everybody. And I'll add one to the list that we kind of touched on a few points during our discussion today, but Adam, you talked about predictive grid operations, and Bree and Rick both talked about the bidirectional communications. When we talk about predictive grid operations, and I think about matching that up against the evolution or development or movement towards energy markets at the distribution level, man, that is really complex. And at the end of the day, it's going to all be about managing data to manage the electrons, and all that has to happen in real to near real time. And I don't think we're that far away from seeing that happen. It begs a whole lot of discussion around technology, data, how the organization within the utility is structured, kind of the sociological aspects of it. Who's going to want to participate in an energy market, whereas others are just like, set it and forget it and send me my bill. So I think it's going to look very different in 5 years, and I think we're all up to our eyeballs in it right now. So it's going to be interesting to see how this all evolves. But we're just about out of time, so I'm going to just take a moment and pause. And first of all, thank our panelists. This was awesome. All the prep work we did. We appreciate all your time and insights leading right up to today. Thanks to Energy Central for providing this forum for this, and of course, thank NetScout for enabling today's session. And I'm going to hand it back over to PJ Davis at Energy Central for wrapping things up.
Thanks, Mike, and thanks, panel. Fantastic conversation today. For our audience, look for an email from us containing the link to the replay. And please take a moment to complete our survey at the end of the session. Your feedback is greatly appreciated. and will be used for future sessions. From everyone here at Energy Central, we hope you have a wonderful day. We look forward to seeing you again on another event. This concludes today's presentation.